you so much for attending this session, DevOps for Data Science. Let me first introduce myself. My name is Marcel de Vries. I'm the CTO of Xperit. Xperit is one of the companies within the Xebia Group. And we focus mainly on Microsoft technologies. Yeah, you introduce yourself.
Yeah, my name is Niels. I'm the CTO of GoDataFest, focusing on data and data science, also on Azure. So hence we'll be here together today.
Okay. Yeah. So if we look back at the conversation we just had, where Microsoft showed us where they're going with data science and AI, I found it very interesting to see that there was this gap between, yes, we know it will be interrupting for our business. Yes, we know it's very important to get it done, but only, what was it, 24% actually deploying it to production. And our story is all about how do we start with the end in mind? Because when you start building these experiments and when you start digging into artificial intelligence and machine learning, one of the important things that we found is that it's great to do an experiment. It's great to dig into the data and figure out a way to create a model. But once you created a model, how the heck do I get it to production? So, in our opinion, you should start with the end in mind. You should start with the idea of, okay, we are going to provide value for our business. This is the data we're going to dig in, and we're going to produce a model out of that, and hopefully that will produce additional results that makes us competitive and differentiating from our competitors. But if you look at the organizations that we work in, I think probably most of you will recognize the picture that I try to draw on my beautiful service. And what you see is that we have the notion of IT change organization and the IT run organization. And this is where we have a major friction point if it comes to all these beautiful experiments and actually getting things to production. Because what you probably will see is that the people here in the change organization are focused to create change, to do impactful things, create new learning models, new AI, new systems that need to go to production. But we have this notion of a run organization that is focused primarily on the stability of the IT component running the business. And this is where you see that there's this red, I always call it the firewall between change and run, which we need to bridge. And for that, you need to think of, okay, if I'm going to do something with data science, I need to think ahead and say, okay, how do I actually get that stuff to production from day one? Because the moment I'm successful with creating such a model and such a piece of AI, I want to run it in production, and that is then a given instead of something that we need to think about later. Because that's the gap that you see between the 24% is actually to production, and you might have come up with some brilliant ideas, but then you always have like the bus coming from the right or the left-hand side, which is then called compliance, security, and all those other parts of the organization that sometimes frustrate us as people that work in IT to get this to production. But they are there for a purpose. They want to run the business in a stable way and don't go out of business because we forgot some regulations or we forgot to anonymize some data or have some biased models and stuff in production that you don't want. So what we need is we need to have another way of looking at how can we create a high-performance organization model that actually caters for this way of thinking, this way of working. And what you see is that we started with some unicorns in the industry that started to try this type of model out. And this is where you see that we create the notion of the value stream, the notion of a product team, so product focus. And that product-focused team will be end-to-end responsible for actually getting it to production. But making that work is quite difficult because, remember the firewall that I just drew in the other picture? So how do you bridge that gap? And that is where we say start with the end in mind, because you need to start the conversation with the people that you put more or less at a risk if you would put something in production without any consulting of their part of the organization. So what you see is that if you would look at the position of a value stream that produces something and gets it to production themselves, that means that we as engineers get more responsibility. We not only build it, but we also run it. that means that we need to have a different perspective on how we build this software, because we need to support it ourselves. We need to have the telemetry coming in so that we know that our system is in good health and shape. We need to be on call 24/7 to actually fix the thing if we put something in production that doesn't work. And we need to find a way to do it in a secure and compliant way. Now, making that happen means that we need to have a look at, okay, how can we, instead of having all these manual barriers that we need to go through in our organization, how can we use IT to make it more fluent, you might say, and where we can just build stuff and have it in production, secure and compliant by default. And this is the essence of what's also known as DevOps in the organization. And some of you might have heard of that. But what is important that does not only work for just building an application that does customer entry data or something like that. This also works very well if you're doing data science and AI. So what you need is you now need to have a team that's end-to-end responsible for the stuff they do. And one of the benefits of this is also that with the talent that you find in the market, they will get more, you might say, autonomy to actually produce something to production. It gives more fulfillment, and that's also what the new workforce is always looking for. So attracting talent is also tied to these other organizational models and getting better performance of your teams. So the idea is, instead of having this firewall in between where we have these manual checklists and we have the risk checklist, like what is it, 32 pages or more that you need to go through, and then we have the compliance check sheet that we need to fill in all the boxes in the Excel sheet. Instead of that, have the conversation with your risk department and ask them not what the means is to get to the goal, but what is actually their goal. And that's the conversation starter we always have. Is the moment we start engaging with a customer, we want to have a conversation with risk. We want to have a conversation with compliance. And why? Because they have spent 30 plus years to build up this big Bible that we need to fill out to get stuff to production. But the world has changed. And the world has changed in such a way that we now have self-service IT. We have the cloud that we can deploy to. That means that I can just, in full automation, create an environment that can run my AI models. Now, given that, I can, instead of having the check marks in my Excel spreadsheet, I can provide evidence as part of my deployments. And that evidence is way more powerful than just having check marks in an Excel sheet. So the conversations I most of the time have with these risk and compliance departments is, okay, so what is it what you're trying to achieve? Yeah, no, you need to fill out this big document. And no, I want to know what you want to achieve. And then we go back to, what does it mean to be ISO compliant? What does it mean to be SOX compliant? What does it mean to be secure? And based on that, we automate everything. And in these steps, we have the steps to validate that we're actually in compliance. We have the validation that we know that we run against, for example, CVE scanning, and that we know that there are no known vulnerabilities of our software before we go to production. And providing that evidence is way, way more powerful than having the check marks. And the funny thing is that if you start with the end in mind and you start with these conversations, then all of a sudden going to production is not a pain anymore, because you will do it every day. And by doing it every day, and very frequent, all of a sudden we can build new things, have new models, new ideas, and get them in production faster, bridging that enormous gap of wanting to be data-driven to actually being data-driven.
Yeah. Thank you. Okay, but obviously not everybody is at the same maturity level, right? Not all organizations are ready to become fully autonomous, fully data-driven, doing the DevOps thing from the start, right? So there's a journey going from where you are now to maybe becoming this data-driven company like the famous companies out there, right? Like the Booking.coms, etc., etc. But what we'll show you is actually this DevOps way of working is something you can already implement at the very start of your journey. Yeah? So let's call this data init in the lower left-hand corner. Let's call that the start. Yeah? Maybe you have some data scientists within your organization. They're building models on their laptop. And how can we enable them still to efficiently be able to push something to production without having to go through all these different hoops? And that's actually quite difficult because, like Marcel explained, the DevOps way of working is now somewhat known. But if you apply it to a data science workflow, it doesn't really seem to fit, because a data scientist, he works with a lot of data, and then he uses code to actually generate more data, right? Because he needs to transform the data into something where you can train your model on. And then with this new data and another piece of code, it actually generates this trained model, right? So it's not your typical, let's say, database plus web server becomes website, right? It's different. It's a different beast altogether. And also this workflow of a data scientist is much more iterative, right? He starts with the original data, applies some code, generates new data, tests if a model can actually be trained upon it, sees where maybe the performance is lacking, and does this same cycle over and over again until he reaches a trained model which has sufficient performance. And so the cycle, this learn, build, measure cycle is actually much more important compared to normal application development. So maybe as a first model, you just predict the mean. See what actually happens if you just predict the mean of a value you want to predict. And you compare against more complex models and actually make the judgment call as well as a data scientist to see if the added complexity of your new shiny deep learning model is actually worth the performance downsides of having to or needing to have like multiple GPUs to train it and to run it. So again, if we look, a data scientist actually builds a couple of artifacts, right? So he combines input data to create derived features, and then his chosen model type he combines with some hyperparameters to actually generate this trained model. And like I said, data science is different because if we just apply the normal, let's say, CI/CD pipeline Marcel introduced just now, we can only check like half or automate, let's say, half of our pipeline, right? We can still validate if the code is secure, and we can still validate if the code quality or if the unit testing is done in a right way, but that's only half of the story. So how are we actually going to verify the data, and also how are we going to actually be able to run this trained model? There's still some code around this trained model which is also should be part. And that's actually where model management comes in. So this is a component from the Azure platform, and it's actually like your, let's say, version or your source code history for your trained models. So as a data scientist, you can actually train your model, push it to this model management, and it will actually store a lot of the information around this model and keep it for you for history, let's say. Okay. Maybe that's a good story. So what is a model doing? So let's say you have a model just predicting the weather temperature, right? So the model is actually combining features like which month of the year it is, combined with maybe how many clouds are there. It's combining all these features to actually make a prediction on what's the weather is going to be tomorrow, let's say. So this data science model is combining some features, knows some experience because it's been trained on a lot of old data, let's say, historical data, knows from experience that maybe in summer temperatures are hot and in winter temperatures are low.
So you always have a question formulated before?
Yeah, so basically historical data, typically you need to say label it, so give it a prediction on, say, okay, in winter time we actually observe the temperature of -2, and because of the, let's say, the input and it knows the output, you can actually make a model which only based on the input can generate a prediction of the weather. But obviously, there's a lot of different ways of modeling this data, right? So there's different types of models, but there's also, every model also has some hyperparameters, so some small dials to tune a model to fit the data better. So this in the end is quite complex. And actually this model management can actually store that for you, right? So a data scientist makes the choice to use a certain hyperparameter. And actually this hyperparameter has an influence on how well a model will perform, how well a model will predict the weather. And model managers will actually capture all this information and make it available for maybe if you in a half year's time want to find out why you chose a particular hyperparameter or why you chose a particular modeling technique, etc., etc.
Is the server different than having a database that has all this information?
It is. I would say okay. So a trained model is like a binary artifact, right? It's like something you cannot read, right? But there's like metadata around it, and this is just a way to store, let's say, the metadata around how you actually compiled, how you created this model. It's a way to store all this metadata. So it is a database, probably. It's like a README file, but it's slightly more complex. It's slightly more automated, but yeah, sure. No, no.
And do you give access to the other people in the company through like SQL statement queries, or how do you let other people see the metadata and the hyperparameters?
Yeah, so this screenshot I have here, that's like the interface of the model management, right? So it has like an API to be able to deploy a particular version of the model to production, but it also has this front end to show, okay, the different performance characteristics, let's say, of the different trained models, and also allows you to choose which model you want to push to production.
So how do data scientists choose a particular model? Because they have several models.
So that's a difficult. Yeah, it's a science maybe. Yeah. It's gut feeling. It's also what they learn in universities, which model applies best for a particular problem. It's experience. It's a lot of things, but it's basically what a data scientist does. Yeah, sure.
You say that the server stores something like the hyperparameters. Is
Yeah.
it just static information?
It is.
Like a dynamic protocol that retunes them with this?
No. It's an end, let's say, storage. So maybe the Microsoft guy this morning explained. So there's things like AutoML, right, which basically try to automatically tune those hyperparameters for you. This is basically just capturing the combination of a certain hyperparameter together with a certain data, produce this performance or this model. Yeah.
Is there any way to write tests for your model?
There is. It depends a bit what you mean, right? So obviously, like I said before, in this, let's say in this picture.
I'm looking for something like unit tests, like writing those,
Yeah. Yeah. Okay. So there's.
validating what you built.
Yeah. So there's multiple ways of doing it, right? So maybe going back to this picture, right? The code in the middle, that's pretty trivial typically to actually write unit tests, right? Because you have some data, you want to manipulate it with code, and you get some other data. That's a unit or something you can test. This part, actually, this code part and getting the trained model, that's a bit more tricky to test. But what you could do is actually say, okay, I have a certain input, and I want to see what output comes out of it. If I'm predicting the weather, and I, as an input, give it like a date in the winter, I want to get at least a temperature which is below 10 degrees, something like that. So you can have some baseline, let's say, unit tests there to more or less know beforehand that performance is okay. An alternative way of doing it is actually just deploying it to production and then looking at the performance in real life, right? So you're not going to do blind push a new version to production, but you're going to have the current version and the new version running side by side. Maybe have the new version be served to 5% of your customers, and then see what the performance is, right? And if it's better, maybe people are buying more stuff or it's better, then you slowly roll out this new version to everybody. But if it's not, then actually you don't, and you keep the old version, let's say, in production.
And of course, depending on your industry, you need to keep track of which model was used by whom, because if they make a buying decision, you need to be tracing it back to the actual model generation. And that's where it's important to have everything automated and registered so that you have this compliance trail to at least show which data caused the new model and which customers use the new model so that you can actually track that back. Yeah.
But if I try to connect what you told about the teams, the DevOps teams,
Yep.
Is this data science person is part of another team doing business applications? Or you were speaking about only data scientist team doing all this?
Okay. That comes back to the cross-functional team. So you can either have one data science group that's doing all the data science and then have people somewhere else building apps and then hopefully they connect together. But what you try to achieve with the value stream idea is that, yes, there might still be a guild or a chapter or a group of people that combine the knowledge of data science, but they are focused on that specific value stream that they are part of, and they are working together with the application developers to actually bring it to production. Yeah.
Okay, I'll skip ahead a bit. Okay, so model management, that's more or less where we left off. And actually this model management, it allows you to slowly introduce this DevOps way of working, or DevOps for data science, into your organization, right? Because now let's say a data science pipeline consists of 3 parts, right? You have a training pipeline. This could be a data scientist running something on his laptop, right? It doesn't necessarily have to be automated. You have your back-end developers creating like an app which allows your model to run. And the combination of the two, right? A trained model and this app allowing a model to run can be deployed to some infrastructure. Yep. Okay, so if you put this again to the maturity level, then initially in this phase you could have your training pipeline still running on your local laptop. Then slowly, if you start this maturity journey, you go towards maybe working in the cloud, maybe doing some remote compute at some point. And if you're a data-driven company, then you're training multiple models at the same time and deploying to production maybe automatically altogether. And then if you look at a more improved, let's say, data science pipeline at this data-driven company scale, then you start to automate actually everything, right? So you have your traditional CI/CD pipeline building your application, being able to run your model in production. But you also have a training pipeline, which is now also running in the cloud as a completely autonomous piece of code training new models. And you have your deployment pipeline. So the nice thing is now, so in this training pipeline, we see actually there's 2 different triggers triggering this training pipeline, right? So if there's a new application being developed by the backend developers, if we're going to deploy the model in a different way, we actually retrain the model. But we're also going to retrain the model if the data really changes, right? If something in the environment around us is changing so radically that the performance of the model goes down, or if we add new data, then actually this new amount of data is going to trigger automatically your training pipeline, which builds your model. The new model automatically triggers your deployment pipeline, which deploys the model to production. And so this now becomes fully autonomous, right? Like Marcel introduced initially, you want to automate as much as possible, but also if I'm a data scientist and in my team I'm responsible for a couple of these models running in production, I want to automate all these pipelines to be able to still have time to work on new models, right? If I'm still doing a lot of manual steps in between, and at some point, after developing maybe 5 or 10 different models, I don't have any more time anymore to actually develop new models because I'm constantly pushing new models to production, etc., right? So these improved data science pipelines are also part of your maturity journey to actually be able to still develop new models while also being responsible for running these in production.
Yeah, and if you take that one step further and then we look at the Microsoft ecosystem specifically, the way you can implement this is, for example, by using a tool called Azure DevOps. So I'm not sure if any of you have learned about Azure DevOps, but that's more or less the development tool that helps you not only store your artifacts in a version control system, but it has the ability to trigger on a change and then start what we call a build pipeline. And that build pipeline can the same way be utilized to say, hey, there was a data change that was significantly enough. Let's start another pipeline, but that pipeline will train my model or retrain my model. And what you can do is then in that training model, for example, or the training pipeline, say, okay, we have some unit tests or at least some tests that validate that we're still within the bandwidth that we accept that the model needs to be. And if that's okay, that could then trigger, for example, a new deployment pipeline, a release pipeline, which is also part of Azure DevOps. And that's where we then say, okay, let's deploy this to production. Now, if you deploy it to production, for example, Azure, there are, I would say, kind of easy ways to say, oh, I just want to have 5% of the traffic coming to my system. Now move to the new model, because we can use, for example, Azure Container Services. We can use the tools like traffic management to manage all the incoming traffic and then route it to just, for this specific user, another model that's going to be used for that particular reason. And setting this up is something that, yeah, once you've done it once, it's quite easy to do. We can even templatize that for your organization. And that's the way we can build these pipelines that are triggered by multiple things. Either the developer makes a change in the application, or the data changes, which needs a change in the model, or the data scientist may say, I'm going to change some of the parameters, and that triggers a training cycle as well. And then actually, when we go through a quality gate, we can then say, let's move this to production. Now, if it comes to compliance, one of the things that we could do, and that's what we often use at first, is that we say, well, all's nice and well, but I want to have a manual check in between, because I just want this person to validate some of that stuff. And if we've done our work right, then this person will say, after like 2 weeks, can you please automate that OK button for me, because I'm getting sick and tired of doing the same thing all over again while I know it's good. And that's the way we build the trust and confidence in the organization, to actually automate it fully. As long as we have, of course, the what we call guardrails in place to make this happen. And this also helps you in, I would say, the mindset in the organization, that automating all of this is just a set of steps that we can do together, and building the confidence all together, actually making the runs to production. And one of the things that we've done at several customers, that we say, well, let's start with the end in mind. So we build an application that has like a very simple model with just calculates the means and doesn't really do anything in production, but we do the full chain. And we go to production as of week 2 with the second sprint, for example. And that's the moment that we build up all the pipelines, and then we start actually building out more of an application. We start building out more of a model, and then that constantly flows to production. And that way we started with the end in mind. We started going to production as of day 1. And I always invite my risk people, I always invite the compliance people to those first sessions, so that they can validate that what we said would be there as evidence is actually available to them at their hands. So that we never have to fear an audit, because an audit is nothing more than, oh yeah, sure, here's the data. Just look at it, and we know it's in compliance by default. So we are here in front of you because we, of course, help a lot of customers doing this. We help customers bridge this gap between successful experiments and actually getting things to production. We do that as Xspirit together with GoDataDriven. Xspirit is the Microsoft team within Xebia that builds out Azure solutions and works together with GoDataDriven on the data science part. And that's where we cooperate with each other, and also set up very effective, cost-effective data science labs. So one of the things that we did together is build a data science lab. Instead of having people work on their laptops, work within an Azure environment where they could push things through, but use compute at their disposal any time of the day they needed it. And doing that in a cost-efficient way You need to learn some tricks, but after you've set it up, then it becomes very efficient and very nice. So secure and comply by default, that's very important. Remember, start with the end in mind. Thank you so much, and enjoy the coffee.